Next up from Laurentian University is Sean Thomas. He's doing a master's in experimental psychology, supervised by Dr. Joel Dickinson. And the title of his presentation is Mental Action Verbs Processing, an ERP Investigation.
Ladies and gentlemen, good evening. My research at Laurentian University has been focusing on the brain representation patterns of mental action verbs. What are mental action verbs? Verbs such as the verb perceive, distinguish, etc. Where this stemmed from is from a study done in 2001 by Pulvermuller and his colleagues, which looked at verbs with verifiable products. That's verbs that you can see other people perform. For example, the verb kick. What he found is that in addition to the activation of a general language processing region, the motor cortex, which is the area of the brain responsible for the actual performance of the action of kicking, was also activated. So what we do in our lab is we look at verbs with no verifiable products, so verbs such as the verb view. So we compare the visual verbs to mouth-related verbs with verifiable products, such as the verb sing. And then we compare them also to auditory verbs, which again are verbs with no verifiable products, such as the verb hear. We do this using an ERP net, which is just like an fMRI. All it does is it captures brain activity across time. And then what we found is that there's increased occipital lobe activity for the visual verbs compared to the other two. Now, what does that mean? The occipital lobe is the lobe responsible for all of your visual actions. So that area is being activated during the semantic processing, so when you process the verb view, for example. What's interesting about it is that it's contrary to what we would think logically, because there's no association, there's no observable action of view that you can associate to the meaning of the word. Yet we find a similar activation pattern between the non-verifiable verbs and verbs with verifiable products. So this is a very interesting finding, and future research is going to look at how we make those associations. However, before we get to answering that question, what we need to do is ensure that our data is not the result of word confounds, because language research is riddled with word characteristic confounds, which typically affect our data. So what we did is we designed an experiment in which we use modality non-specific verbs. So verbs such as the verb perceive and distinguish, which would make sense in the visual context as well as the auditory context. You can perceive visually and auditorily. So what we do is we embed it in those two contexts respectively and then compare the brain activity to themselves. That way, there's no word characteristic confounds which could affect the data. So currently, data collection is going on for that study. But where this would be useful is, for example, in the Human Brain Project, a $1 billion project which aims to amalgamate all of our knowledge about brain activation patterns into computer simulation software. And then what we can do is better predict health outcomes of brain damage. So my research will hopefully contribute to such a goal. Thank you.